This video is on L'Hopital's rule. It's a calculus technique for finding limits when we end up in indeterminate form. Now, what is indeterminate form? We try to take a limit and we end up with 0 over 0 or plus or minus infinity over plus or minus infinity. Sometimes we can handle that without resorting to L'Hopital's rule. In other cases, we would want to go there. Limits are a way of avoiding division by 0. Since a limit is concerned, we're getting a function, getting function values near a point in a function's domain, but not actually at the point where the domain is undefined or having a 0 in the denominator. Cancellation often solves a problem of a division by 0. Normally, the issue is resolved using algebra or trigonometry. As a simple example, find the limit of f of x over g of x, where f of x is x squared minus 2x plus 1, and g of x is x squared minus 1, as x approaches 1. Well, we have the limit as x approaches 1 of x squared minus 2x plus 1 over x squared minus 1, which if we plug 1 in, we end up with 1 minus 2 plus 1, that's 0, over 1 minus 1, that's 0. Well, that just would not normally be possible in algebra, but in limits, what we can do is factor and end up with x minus 1 times x minus 1. Factor the denominator, and we end up with x minus 1 over x plus 1. Cancel a problem away and end up with 0 over 2, which is 0. This is possible because we're not actually looking at the value x equals 1. We're looking at values very close to 1. L'Hopital's rule actually has two spellings if you are looking it up for some reason, like say more practice. Sometimes it's a good idea to have practice problems, and you might want to look up the topic. When the limit as x approaches a of f of x over g of x equals 0 over 0, the limit as x approaches a of the derivative of f with respect to x over the derivative of x of g of x with respect to x is going to be the same thing. Two limits have the same value. This one we might not be able to figure out. Maybe we can find something here, and often we can. For example, find the limit as x approaches 0 of 3x over e to the x minus e to the negative x. The limit as x approaches 0 of 3 times x over e to the x minus e to the negative x is 3 times 0 over 1 minus 1, 0 over 0. We can look at that all day and not be able to factor or do anything, any fancy little algebraic trick, so we try taking the derivatives. The derivative of 3 to the x with respect to x is 3. The derivative of e to the x minus e to the negative x dx is e to the x plus e to the negative x. So our limit, our original limit here, is equal to the limit of the ratio of the two derivatives, which is 3 over e to the 0 plus e to the 0, or 3/2. Now we know this limit that we started with, x approaches 0, 3 to the x over e to the x minus e to negative x is 3/2. Well, what happens if we take L'Hopital's rule and end up with still an indeterminate form? The L'Hopital's rule is transitive. That means that this one equals this, the ratio of the functions, the ratio of the derivatives. And when we take the limit of the ratio of the second derivatives, we still have a valid application of L'Hopital's rule. So if I can find this limit of the ratio of the second derivatives, I know the limit of the ratio of the first derivatives, which means I know the limit of the ratio of the function, and so on. I can go out as many times as I have to. Well, let's look at this one. Find the limit as x approaches 0 of sine x minus x over x squared. We tried just plugging in, which we always hope will work, and we end up with 0 minus 0 over 0. 0 over 0, indeterminate form. We tried L'Hopital's rule. We take the derivative of sine x minus x. We find out that's cosine x minus 1. We take the derivative of x squared, and we find out that's 2x. Now we try plugging in. Cosine 0 is 1. 1 minus 1 is still 0. 2 times 0 is 0. Right? Again, we end up in indeterminate form. So we try L'Hopital's rule again. The derivative of cosine x minus 1 is simply negative sine x. The derivative of 2x is 2. Now we end up with 0 over 2, which is 0. The other case, where we end up with plus or minus infinity over plus or minus infinity, is exactly the same. We take the ratio of the functions, the limit of the functions, and it's the same as the ratio of the limit of the derivatives, the quotient of the derivatives of those functions. Example. Find the limit of e to the x over x plus 6 as x goes to infinity. The limit of as x goes to infinity of e to the x would normally just plugging in give me e to the infinity, which is infinity. And 6 plus x, just plugging in, gives me infinity plus 6, which is infinity. Again, we have an indeterminate form. So we try taking the derivatives. The derivative of e to the x dx is going to be e to the x. So I have the limit as x approaches infinity of e to the x over the derivative of 1x plus 6 is simply 1. So I end up with e to the infinity over 1, which is infinity. Now I know what this limit is. E to the x over x plus 6 is infinity.